change. Things change when you cool them down. And so if we were to take one of these little flowers, this flower is over 200 degrees hotter than this liquid in here. And we put it in there. Sorry, flower. The liquid literally boils. The flour makes it boil.
Listen to it, yeah.
And the flour gets pretty cold. And it still seems to be alright when you pull it out. Except when you flick it. In case you missed it, we'll try it on another one over here. The properties change quite a lot, so we'll cook that into there. Well, we're going to cook it, take it down to minus 200, and the properties change a very large amount. We put our finger in there, if you hit it, it would just break off. We're not going to try that tonight. Okay, take that out, the same kind of thing. Okay, now that happens because the particles get slowed down, they get squeezed together, and they take up less room. And most of you know that. And if you are riding a bicycle or a motorbike at liquid nitrogen temperatures, your tyres would change too. So we'll put the tyre in there. And down in Antarctica it doesn't get quite as cold as that, but that rubber has changed, as you will see. Now, I haven't been to Antarctica, but I believe that tyres do get brittle there, and you hit a stone and great chunks fly off. Tennis balls change. Ordinary tennis balls do that kind of thing. And so we'll have a wee look. Where's my cold
I want to play tennis.
So we've got a very cold tennis ball in here right now, and just give it a chance just to get cold. Okay, and you'll see that it's sort of lost all its balance. But rather interestingly, we can take some of this stuff. Now, what's that? What's it look like? Rubber? Flexible? Okay. What we're going to do is we're going to take some of that rubber and put it in the fish and chip basket and just cool it down in there for a little bit. Put a bit more nitrogen in there, it's getting a bit down the bottom. We're going to cool this rubber down, and what will happen is the particles will get close together and the rubber will become quite hard, as you will see in a moment. And the properties of the way things behave becomes quite different. Now, I want to be a bit careful here. I think these gloves are in order. I burn you my fingers. And so we'll just see if we can get that rubber nail out of there. Because it in fact finishes up being a rubber nail. Because what we can do with that now is we can just nail it straight into the wood. Now, something else we can do, this is another piece of rubber, we'll just get rid of all this stuff here. What we'll do is we'll put some nitrogen into this flask, and you'll actually be able to see it. The flask is pretty hot, so a fair bit of it boils away. And so we'll just pour that into there. I hope I've put enough in there. And I think I need my gloves for this experiment. So we'll do that. And then we'll get this bit of tubing here, which is pretty flexible, as you can see. And what we'll do is we'll just put that into there. That wasn't what it was intended to do, but we'll just rerun that a little bit more. Right, and then come back in the jungle, we'll put some more into there. We'll have to have another go. Did you see what was happening to the rubber? Maybe you didn't. Alright, we'll try and make that stay there this time. Okay, here we've still got this flexible rubber. We'll have another wee go with this. Okay, the rubber stays totally rigid.
Really? It goes
So
through.
that rubber has now become very, very cold. So you can see this water vapour coming off that and gradually will sag and become the way it was before. Now, in each of these cases, we are slowing the particles down, we're making things more solid. That will gradually disappear. But if I was at school, I'd be talking about hot air, because teachers have a fair amount of hot air, as some of you kids will know. And they go on and on, don't they? Your teachers go on and on? Okay, and so if you're asked for hot air in a school lab, well, there's not a lot of problems, just teaching, just blowing it, will you? And so we finish up with a balloon full of hot air. Now, I wonder what will happen. You watching your ears? Okay, and we're just going to pour some liquid nitrogen over this hot air balloon. What's happening? The air particles are cooling down, taking up less and less space. And the intriguing thing is, what you can do now is you can blow up the balloon from the outside.
Beautiful.
I bet you've never blown up a balloon up from the outside. Now, what I've got here is a small beaker, and I'm going to put just a little bit of liquid nitrogen in there. In fact, I'm going to put 30 millilitres of liquid nitrogen in there, just to allow you to see it. It sort of looks like water. It's not like water, but it sort of has the same colour as water. And that's probably about 30 mils. Maybe I need to put a little bit more in there. Now, there are some chemists here, they know all these things. Well, they think they know, but they don't talk about it very well sometimes. And there's 30 millilitres, that's about 6 teaspoons of liquid nitrogen. When that turns to a gas, it will fill all these bottles. 25 litres of it. So all of that little bit there will fill all of that. And I thought we should try that by putting some liquid nitrogen in these flasks, and we'll see if we can make the liquid nitrogen blow up and balloon. Alright, now I need the gloves again. Things are going to get a little cold around here. We alright, Graham? We'll keep going?
Oh yeah.
Yeah, okay. Right, well, we'll put some liquid nitrogen in there. I'll put about, I don't know, about that much in. I don't know whether that much is enough. But we'll put some more of that much in there. And then what we'll do is we'll get a bong. We'll put that into there. And we'll just make sure we put that into there, and we'll put this one into there, and we'll just see what happens as the liquid nitrogen turns into gaseous nitrogen, and it takes up a lot more space, as you can see. Okay, and she's boiling away there again, taking up a great deal more volume. Where's it going to go, guys?